Hi, my name is Shruti Arya, and today I'll be presenting my demo session on polynomials. And before we begin, a little bit about myself. I have a bachelor's degree in computer science engineering, and right now I work for a custom research firm, Aranka, and teaching has always been a passion, so I hope that Vedantu will give me more opportunities so that I can pursue this passion. And before I begin the session, Devina, I wanted to inform you that I was not able to use that image upload tool of your whiteboard. So what I have done here is I have written with the stylus in the presentation, and I hope we'll sort this out in the coming sessions. And so I'm recording this using iSpring FreeCam software. So due to the time constraint, what I have done is, although I prepared the full session, what I'll be doing today is working on explaining the basic concept, what a polynomial actually is, so that the student can move ahead and then understand the concepts like degree of a polynomial and the zeros of a polynomial, and then move along to higher concepts like remainder theorem and factor theorem. So coming to what a polynomial actually is, we'll break down its definition. So a polynomial, it says, is an algebraic expression. Let me choose another color here. An algebraic expression where the powers of the variable terms is a whole number. Now, see, this is not a textbook definition. These are what my approach will be, is to have definitions which the student can understand easily. So first thing first, an algebraic expression. So we consider a polynomial, but it has to be an algebraic expression. So we'll see what an algebraic expression is. Although we have studied this, but understanding the basic definition is, in my opinion, more important. So an algebraic expression consists of, again we'll have the simple definition, consists of constant terms, variable terms, and certain operations. So what first, so constant terms are only integers. The variable terms are like those variables like a, b, x, y, which can have any value, which can be substituted for any values. And the operations, mathematical operations, include addition, subtraction, multiplication, division, and the power operation, the exponent. So when we consider this, 2x square plus 3x plus 4. Now in this, when you see constant, these coefficients are the constant, and the x is the variable term here. So and and the operation that we have used is addition here. Now notice that only these operations are allowed. Any other operation like remainder operation or other these things are not allowed. And another thing, more important thing to notice is the constant terms have to be integers. So if in place of 2 it was 2.7, this won't be considered as an algebraic expression. Now coming back to the definition of a polynomial, see, it's an algebraic expression where the powers of variable term is a whole number. Okay, now let us add a new whiteboard here, and so consider this: 3x square plus 15x. Let us have a simple expression here. So 3x square plus 15x. Now in this, the variable term is x here, x here. So what are the powers of, if we see the powers here, it's 2, this is a whole number, and here it is 1, which is also a whole number here. So this is satisfying our definition that the power of the variable terms have to be a whole number. Now consider this. polynomial, or an algebraic expression we should start with. So 3x cube plus 5 here. Now, is this a polynomial? Okay, to answer this, we will check the variable expression here. It is x and the power is 3, and this has only the constant term here, and this along with the variable expression here, the constant term, in this case we also call them as coefficients. So this is the coefficient here, and this is just a constant term. So this is also a polynomial. Let us consider a third case here. So if I say just 5, now is it a polynomial? What we'll find here, what the important thing to notice here is, we do not have a variable expression here, right? But consider this, if I were to write this as 5 and x to the power 0. Now we know 0 is a whole number, right? So in this case, this is same as just our expression 5. So for these cases, when there is only a constant term here, we consider the case where the power of x will be 0. So in such cases, what we do is, what we take these are our constant polynomial. So these are our constant polynomial. So we have a clear case, an algebraic expression. Always remember that it has to be an algebraic expression, okay? And the powers of the variable terms is a whole number. Remember, a whole number. Negative numbers are not whole numbers, so they won't be considered as polynomial. So if it was 5x to the power minus 2, this will not be a polynomial. Okay, now before we leave this session, just to make sure that we are fine with the power concept here, so I always remind, I would like to remind people who I teach. So 10 power 2 is 100, 10 power 1 is 10, and 10 power 0 is 1. Why this is important is I want the students to remember, do not confuse yourself, because we will be moving towards zeros of a polynomial. So zeros should not be confusing us. So 10 power 0 is 1. Now 10 power minus 1 is 1 by 10. And 10 power 2 is 1 by 100. So I will always keep this chart handy, these instructions handy, so that people don't confuse with the powers. So I would like to end my demo session here. And since I did prepare a few slides on remainder theorem and factor theorem, but I prefer that due to time constraint, I stick only to the definition of a polynomial so that this stays with them, the basic concept. So thank you very much, and I hope to get a positive response from you. Thank you and have a nice day.